Dear students, I am Dr. Amir Fawaz Zahoor, and in our previous video we talked about the synthesis of pyrrole. In this video we will talk about the reactions of pyrrole. Pyrrole is also a very reactive heterocycle and it reacts with different reagents. For example, it undergoes electrophilic substitution reaction, and the general mechanism is the lone pair shifts here and this pi bond shifts here and this bond attacks on the electrophile, and as a result we get this type of form. Now it can resonate, this bond can shift here, and as a result we get positive charge on this position. Also it can shift here, and in this resonance contributing structure we get positive charge on this carbon. So these are general reactions with electrophiles. Now some more reactions. Okay, pyrrole gives different electrophilic substitution reactions. For example, in presence of N-chlorosuccinamide, which is abbreviated as NCS. In this case, we get 2-chloropyrrole, and when NBS, N-bromosuccinamide is used, we get 2-bromopyrrole. When bromination is carried out with bromine, 2, 3, 4, 5 tetra substituted pyrrole is obtained, and in case of nitration it can be carried out in the presence of nitric acid in acetic anhydride at -10 degrees centigrade, and 2 nitropyroles are obtained. And sulfonic acid derivatives of pyrrole can be obtained through pyridine sulfur trioxide complex. When pyrrole is reacted with sulfuric acid, in general we get polymers, and as a result protonation of carbon 2 takes place here, protonation of carbon 3 takes place. So in case of sulfuric acid, when sulfuric acid is treated with pyrrole, we get protonated pyrroles, and in which this is 80% at position 2, and here at position 3 this forms in 20%, and as a result of this protonation polymers are obtained. So these were electrophilic substitution reactions. Now next is acid-base reactions. Pyrrole behave as NH acid because the proton to be abstracted resides on nitrogen, and when nitrogen donates a proton, it is called NH acid, and its pKa is 17.51. so different bases can be used. For example, sodium hydride will react with pyrrole to abstract the proton, and as a result we get this plus H2. If we use Grignard reagent, for example methyl magnesium bromide, now in this case Grignard reagent will also react as a base, because we know that Grignard reagent has negative charge on carbon portion and it is a very reactive and strong base, so it would also abstract the proton from here and we will get this, or like this. And if we use N-butyl lithium as base, we will get lithiated pyrrole plus N-butane. So these were acid-base reactions. Next reactions are Houben-Hoesch acylation. In this reaction, nitriles are reacted with pyrrole in the presence of acid and two acyl pyrroles are obtained. We see the mechanism. So in the first step, nitrile is treated with HCl, and as a result we get protonated nitrile, and it can be represented as this as well. Now it will react with pyrrole. This lone pair will shift here, this bond would shift here, and this would attack here, as we have seen the general mechanism for electrophilic substitution reaction. And as a result of this, positive charge on nitrogen, here will be hydrogen, and this is imine and this is R. Now this proton will be abstracted or will be removed because aromaticity of this system has to be restored. So it will shift here, it will be shifted here, and it will shift here to restore the lone pair. This proton would be abstracted by imine nitrogen, and as a result of it, this iminium ion would produce. This iminium ion can be hydrolyzed with water to give corresponding 2-acyl pyrrole as the product. So this was Houben-Hoesch acylation reaction. Next is reaction with diazonium salts. When pyrroles are reacted with diazonium salts, we get diazo compounds. For example, in this case, these two react together, and the compound is obtained. So next reaction. Next is preparation of dipyrrolyl methanes. This can be done by the reaction of pyrroles with ketones in the presence of acid. And this protonated carbonyl compound or ketone will react with pyrrole. This will shift here, this bond will shift here, and again it will attack here. This bond will break and lone pair of oxygen would be restored. And as a result of this, we will get this intermediate. Now, because aromaticity has to be restored, so this proton would be abstracted, this bond would shift here, this will shift here, and this bond will shift here to restore the lone pair of nitrogen. And then we have this leaving group, and again this leaving group would be removed to get this intermediate. Now, other molecule of methyl pyrrole which is present in the medium will react with this. This will shift here, this will shift here, and this bond will attack here. This will shift here, this bond will shift here, and this will shift here. As a result of this, we will get this, and this will lose proton. This will shift here, and it will shift here. And final product, dipyrrolyl, because there are two pyrroles, dipyrrolyl methanes are obtained, and they are important because they can be treated with different transition metal salts to give colored compounds. So this was preparation of dipyrrolyl methanes. Next is preparation of 3-acyl pyrroles. From corresponding pyrrole. For example, we have this pyrrole. It can be treated with sodium hydride. As a result, proton from here would be removed and minus H2, and we will get this. this can be treated with benzene sulfonyl chloride. Now because proton has been removed, we have negative charge here. It can be used as nucleophile, so it would attack here and chlorine would be removed as chloride, and we will get N sulfonyl derivative, and this can be used in Friedel-Crafts type reaction, RCOCl acid chloride in the presence of aluminum chloride, and we get acylation at 3 position, and protecting group, this protecting group can be removed using sodium hydroxide to get 3-acyl pyrrole. Now we have prepared 2-acyl pyrroles. Previously this is 3-acyl pyrrole. So we can use protection deprotection methodology in this case to prepare 3-acyl pyrroles. If we use directly deprotonated pyrrole and react it with this, we get acylation here. Therefore we have to use protecting reagent like benzene sulfonyl chloride, and reactivity of nitrogen is masked. Then under Friedel-Crafts acylation conditions we get 3-acyl N-protected pyrrole, which is then deprotected using sodium hydroxide. So if we are asked to prepare 2-acyl pyrroles or 3-acyl pyrroles, we have to use the particular methodology or corresponding methodology with which we can prepare these molecules. Another method involves the reaction of N-methyl pyrrole with N-butyl lithium. In this case, if nitrogen is protected here, then deprotonation would take place at this position. Earlier when we reacted N-butyl lithium with pyrrole, this was not occupied, here hydrogen was present. Therefore when we use N-butyl lithium, now proton from carbon 2 would be abstracted. So here Li, or we can show negative charge here, positive here. Now this has the possibility to react with different electrophiles. For example, if we use alkyl halide, so alkylation would take place at this position. And if we react it with an electrophile, for example carbon dioxide, we get the carboxylates, and they can further be used to react with alkyl halides to give corresponding esters. So depending upon the given molecule, we can prepare corresponding pyrrole derivative using this methodology. Now we have some addition reactions of pyrrole. Pyrrole reacts with maleic anhydride via Michael reaction. This bond shifts here, this here, and this attacks here, and we get this intermediate negative here, and this proton is abstracted, this is shifted here, this bond shifts here, and it is shifted here, So as a result, Michael addition of pyrrole to maleic anhydride takes place. Next reaction, like furan, pyrrole also undergoes Paterno-Buchi reaction. And in this case, N-methyl pyrrole can react with ketones in the presence of sunlight, and we get oxidants as product, and this can isomerize to give this product. Pyrrole can react with dichlorocarbene, and it shifts here, here, and here. As a result, we get this, and this proton is abstracted, this shifts here, this is here, and we get this, and upon treatment with a base, we get pyrrole to carboxyaldehyde, and this reaction is Reimer-Tiemann reaction. Now next reaction, pyrrole reacts with dichlorocarbene via cycloaddition as well, and as a result of it, cyclopropanes are formed, and in this bond shifts here, this shifts here, and this is eliminated, so minus Cl minus H positive, and as a result of this we get 3-chloropyridine. So this was all about the reactions of pyrrole. I hope you have completely understood the reactions, and if you find any question, query or confusion, you can leave your question in the comment box. Thanks.